This is a problem that sometimes causes a few difficulties, so I thought we'd work through it. It says tectonic plates are large segments of the Earth's crust that move slowly. Suppose one such plate has an average speed of 5 centimeters per year. Part A is what distance in meters does it move in 23 seconds at this speed? Now, your numbers probably weren't the 5 centimeters and 23 seconds because these are randomized, but of course the technique will be the same for the solution. So let's work through it. The first thing we need to do is to convert because we're given a speed in 5 centimeters per year, and we want the answer in meters. And it also wants to know how far it moves in 23 seconds. So we want to convert from 5 centimeters per year to meters per second. We have a distance conversion then and also a time conversion. So let's do that first. We've got 5.0 centimeters per year. Let's do the distance conversion. We know that 1 meter is 100 centimeters. So that takes care of distance. Now we need to do the time conversion. Maybe we know how many seconds are in a year, but probably not. So we can do that in pieces if we like. We've got 1 year is about 365 days. Times 1 day is 24 hours. One hour is 60 minutes. And 1 minute is 60 seconds. So if we did this right, it should leave us with the meters per second. Let's see what we've got. We've got centimeters cancel. Leaves us with meters up here. Years cancel. Days cancel. Hours cancel. Minutes cancel. That leaves us with meters per second, which is what we want. If we multiply that all out, we will end up with about 1.6 times 10 to the minus 9 meters per second. A very small number, we'd expect that because a continent doesn't move very far in just one second. Okay, so there's our speed in meters per second. Now to find the distance, we know the distance is equal to velocity. In this case, it's really speed times time. That's equal to 1.6 times 10 to the minus 9 meters per second, our speed, times the time we're given of 23 seconds. Work that out, and you should get about 3 times 10 to the minus 8th meters. So that's our answer for part A, 3 times 10 to the minus 8 meters. Okay, now part B says what is its speed in miles per million years? We could work with the speed that we found from part A, but probably it'll be a little bit easier if we work from our original numbers. So we have, again, we know that that our speed is 5 centimeters per year. So we've got 5.0 centimeters per year. Now we want to convert our distance to miles. So how many centimeters are in a mile? Well, we know that 1 meter, again, is 100 centimeters. And we know that 1 mile is about 1,609 meters. That'll leave us with miles instead of our meters. So that gives us, multiply that, about 3.11 times 10 to the minus 5 miles per year. Okay, good. So now we want to find what that speed is in miles per 1 million years. So we need to multiply that by 1 million years. Again, distance equals velocity times time equals 3.11 times 10 to the minus 5 miles per year. That's our speed. Times our time, which is 1 million years. We can write that in scientific notation if we like. 1 million is 10 to the 6. So 1 times 10 to the 6 years. Multiply that. We still have the 3.11. The 10 to the 6 multiplies times the 10 to the minus 5th. And that gives us 3.1 times 10 to the 1st miles, or if we like, 31 miles. So it moves 31 miles in 1 million years. There we have it.